Scene script. Have you ever wondered what would happen if there was no gravity on Earth? Now that's a question that tickles the imagination, isn't it? Gravity isn't just some abstract concept that scientists throw around. It's an invisible force that's constantly at work, pulling objects towards each other. Think of gravity as the cosmic glue that keeps everything in its place. Imagine you're holding an apple. When you let go, it falls to the ground. Why? That's gravity at work. It's the force that pulls the apple, and indeed all things, towards the center of the Earth. Without it, that apple wouldn't fall, it would just float away. But gravity doesn't just keep our feet firmly planted on the ground, it's also the reason our moon doesn't go wandering off into space. Instead, it's caught in Earth's gravitational pull, causing it to orbit our planet. And it doesn't stop there. Gravity is the invisible tether that keeps Earth and all the planets in their orbits around the sun. In essence, gravity is the master puppeteer of the cosmos, directing the movements of planets, moons, and stars. It's a fundamental force that shapes our lives and the universe around us in ways we often take for granted. Gravity is a fundamental force that shapes our lives and the universe around us. But what if it disappeared? Now that's a thought to ponder. Let's dive into it in the next scene. Imagine a world without gravity. It might sound fun, but the reality would be very different. The absence of gravity would mean that there's nothing binding us to the surface of the Earth. Just as astronauts experience weightlessness in space, we would all start floating around. Anything not secured down would drift upwards. Cars, trees, houses, even the oceans would lift off into the sky and eventually into the cold vacuum of space. But the effects wouldn't stop there. The Earth itself, which is held together by gravity, would begin to lose its round shape. The centrifugal force from the Earth's rotation, unopposed by gravity, would cause the planet to flatten and spread out like a pancake. Now let's talk about the air we breathe. Our atmosphere, which provides us with oxygen and protects us from harmful solar radiation, is also held in place by gravity. Without it, the atmosphere would slowly drift away into space, leaving the Earth exposed to the harsh conditions of the cosmos. The immediate effects would be catastrophic, but the long-term consequences would be even more devastating. Without an atmosphere, temperatures would fluctuate wildly between extreme heat during the day and freezing cold at night. Life as we know it would be unable to survive these harsh conditions. Furthermore, without gravity, the water cycle would cease to exist. There would be no rain, no clouds, and no bodies of water. The Earth would become a dry, barren wasteland. In essence, gravity is the glue that holds our world together. It shapes the Earth, holds our atmosphere, and allows life to flourish. Without it, the Earth would be an inhospitable, lifeless rock floating aimlessly in space. As you can see, life as we know it would cease to exist without gravity. Gravity doesn't just keep us grounded, it also plays a crucial role in the cosmos. From our blue planet to the farthest reaches of space, gravity is the invisible force that binds the universe together. It's like the cosmic glue that sticks the stars in the sky and keeps the planets in place. Let's start with stars, the twinkling lights that grace our night sky. Stars, like our sun, are born from clouds of gas and dust, known as nebulae. But how do these nebulae transform into brilliant stars? The answer lies in gravity. The particles within these nebulae are drawn together by gravity, creating a dense core. As more and more matter is pulled into this core, it becomes hotter and denser until, finally, nuclear fusion begins, and a star is born. Without gravity, these celestial nurseries would remain mere clouds, never condensing into the fiery furnaces we know as stars. Moving on to galaxies, gravity again takes center stage. Galaxies are vast collections of stars, gas, dust, and dark matter, all held together by, you guessed it, gravity. Our Milky Way, for instance, contains hundreds of billions of stars, all kept in their place by the gravitational pull of the galaxy's center. Without gravity, galaxies would disperse, their stars scattering like cosmic confetti across the universe. Closer to home, gravity is what allows planets to have atmospheres and weather. The gravitational pull of a planet holds onto its atmosphere, a layer of gases that protect and sustain life. It's gravity that keeps our atmosphere from escaping into space, maintaining a breathable environment for life on Earth. Weather patterns, too, owe their existence to gravity. It's gravity that causes the flow of air and water, creating wind and ocean currents, and driving the cycle of evaporation and precipitation that's so crucial to our planet's climate. Without gravity, the universe would be an entirely different place. From the birth of stars to the formation of galaxies, from the existence of atmospheres to the creation of weather patterns, Gravity is the unseen force that shapes our universe, making life as we know it possible. Gravity might seem like magic, but it's actually a well-understood scientific principle. So, let's dive into the science behind gravity. To kick things off, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It's what keeps us firmly planted on the ground and what makes the Earth orbit the Sun. But how does gravity actually work? Well, that's where Albert Einstein and his theory of general relativity comes in. According to Einstein, gravity isn't just a force, it's the curvature of space and time around a mass. Imagine a rubber sheet stretched tight. If you place a marble on it, the sheet will dip under the weight, creating a sort of well around the marble. Now, if you roll a smaller marble near the larger one, it'll be drawn towards it, spiraling down into the well. That's essentially how gravity works. The Earth, like the larger marble, warps the space around it, drawing smaller objects, like us, towards it. Now, the more mass an object has, the deeper and wider its well, and the stronger its gravitational pull. That's why the Earth orbits the Sun, and not the other way around. The Sun, being much more massive, creates a much deeper well in space-time. But what's interesting is that gravity is actually the weakest of the four fundamental forces of physics. It's about 39 orders of magnitude weaker than the strong nuclear force, the force that holds atomic nuclei together. But because gravity has an infinite range and adds up with mass, it dominates on the macro scale, shaping the structure of the universe. So gravity might seem like an everyday, ordinary thing, but it's actually an extraordinary force that holds the universe together. It's the reason planets form, stars shine, and galaxies spin, and it's the reason we're here talking about it. Understanding gravity helps us understand the universe itself. So why is it important to understand gravity? Well, the understanding of gravity has a significant impact on various aspects of our daily lives and beyond. Let's start with something as simple as the design of buildings and infrastructure. Architects and engineers must take gravity into account when designing structures. They must ensure that buildings can withstand gravity's constant pull, preventing them from collapsing under their own weight. A structure's stability, its ability to bear load, and even how water flows through its pipes, all hinge on our understanding of gravity. Moving towards a more technologically advanced application, consider the realm of satellite technology. Understanding gravity allows us to predict the orbits of satellites and space probes with astonishing accuracy. These artificial celestial bodies are launched with a specific velocity at a specific angle, calculated to perfection, so that they fall towards the Earth just as fast as they move forward, ensuring they stay in orbit. This understanding of gravity enables us to enjoy GPS navigation, weather forecasting, and even international communications, which are all facilitated by satellites. But it's not just about what's happening here on Earth. Understanding gravity is also key to exploring the vast expanse of the universe. It's gravity that keeps our feet on the ground, but it's also gravity that keeps the moon in orbit around the Earth and the Earth around the sun. It's gravity that guides the path of comets, forms galaxies, and even bends the path of light itself. By studying gravity, we can explore the mysteries of black holes, the birth of stars, and the very origins of the universe. Moreover, as we delve deeper into the understanding of gravity, we might even stumble upon new laws of physics. For instance, the current theories of gravity are incompatible with quantum mechanics, the theory that describes the behavior of particles on the smallest scales. Resolving this conflict could lead to a unified theory of physics, opening up new frontiers of knowledge. In essence, understanding gravity is not just about knowing why things fall down, it's about understanding the invisible strings that hold our world and indeed the entire universe together. It's about predicting and harnessing this force for our practical needs, and it's about pushing the boundaries of our knowledge. So next time you drop something, remember, it's not just falling, it's being pulled by an invisible force that holds our world